Starship takes flight once again, and the telescope looking for the glue of the galaxy. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. SpaceX's Starship took its 12th flight last week, testing a new version of the rocket that can send massive amounts of stuff into space. It's also slated to take NASA astronauts to the lunar surface. It's been a rocky road to get to this point, and all eyes have been on this vehicle. We'll speak with NPR's senior editor and correspondent, Geoff Brumfiel, about this critical test flight and SpaceX's plan to take the company public. Then, what holds our galaxy together?
We don't know what it is. It's called dark energy. So trying to look essentially back in time as we look back billions and billions of years at how the galaxy's separated, to try to understand what that phenomena is.
We'll speak with NASA's Mark Melton about the Roman Space Telescope's search for dark matter and planets outside our own solar system. That's ahead on Are We There Yet?
Eight, 7, 6, 5, 4, 3, ignition. We have liftoff.
That's the sound of SpaceX's Super Heavy booster roaring to life. It's 33 engines firing to launch the Starship spacecraft on a test mission from the southern tip of Texas. It's a critical demonstration for the commercially designed to develop spacecraft. The future of SpaceX's satellite delivery business depends on it, and so do NASA astronauts that want to step foot on the moon. The 12th launch of Starship comes just as the company also announces another bold endeavor, taking SpaceX public. Geoff Brumfiel is a senior editor and correspondent at NPR and has been following this mission and SpaceX. He joins us now. Geoff, welcome back to Are We There Yet?
Oh, it's a pleasure to be here.
It's always great to chat with you, Geoff. I know you've been following SpaceX and Starship for a while. Let's talk about this 12th test. This was a very crucial moment for SpaceX, was it not?
Yeah. I mean, this was a big one, and not necessarily entirely for technical reasons. I mean, there's sort of two sides to this. It was the first flight of their V3 spacecraft, the version 3 of Starship, which we can talk about if you want. But it was also the first flight after they had dropped their documents to go public, which was much anticipated. I've been anticipating it for kind of years because I've always wondered about SpaceX's business. And, analysts I spoke to said like how the flight went really would determine the valuation of the company.
So lots at stake there. Let's break this down. Let's talk a little bit about the V3 version of the vehicle. This was quite different than other vehicles that have launched before. Tell me a bit about what's changed.
Yeah. Okay. So what's changed are where to begin. Let's start with the engines. I think that is probably the most significant change. It's using these Raptor 3 engines, which are a major upgrade over the Raptor 2s. The main thing is that the shielding is now all integrated into the engine, which means you need less shielding on the spacecraft itself, which is very heavy and actually created some problems in the V2 version of the rocket. So that's a positive.
And there's a lot of them, right?
Well, yeah. I mean, there's 33 on the stage 1 booster, and then Super Heavy, they call that. And then on Starship itself, there's 3 regular sea-level Raptors, and then there's 3 of what are called vacuum Raptors, which are designed to operate in space. As far as I can tell, the main thing is they have like a bigger thrust chamber. They have a bigger bell on them. I don't know. There's probably a ton of other differences, but excuse me. But that means there's 39 rockets in total there, or 39, engines in total there. And then the other changes in the Super Heavy booster, let's talk about that. That's where a lot of the changes are. So they have a whole new fuel system to fuel the engines. They have a whole new control system where they used to have these things that look kind of like spatulas called grid fins they use to steer the rocket. They had 4. Now they've gone down to 3 in like a T formation on the sides and the bottom of the booster. And I think those are kind of the big ones for Super Heavy. And then Starship, obviously they have the new engines there as well. I think they have a new avionics package and a few other things. overall, I was speaking to Scott Manley, who I'm sure you're familiar with and your listeners are probably familiar with, popular YouTuber, and he was sort of talking about it looks much more refined. This looks like a more actual rocket instead of, as he put it, a couple of grain silos sort of welded together.
Yeah, the original versions of those starships always looked like a steampunk nightmare, and now it definitely looks far more refined as well.
Yes, exactly.
With what sounds like
Totally.
a lot of new technology on this vehicle, you might expect some hiccups at the pad before it launched. There was almost a launch attempt the first time out, right, Geoff?
Yeah. And I mean, the hiccup, there was a hiccup, but it was with the pad. And I should have mentioned that too. This pad is radically changed. There's a new flame diverter. There's hold down clamps that are actually powerful enough to hold down the rocket while they cycle the engines. They've made changes to the grab arms, for Mechazilla, the tower that grabs the rocket. So there's a lot going on at the launch site as well. And so interestingly enough, as far as I can tell, the real thing that held up launch the day before wasn't necessarily Starship. It was the pad. Some problems with the arms there. But and they sent it on the second try.
You've been covering space long enough, Geoff. You know that delays happen all the time. But so to get it off in two is pretty impressive. What was SpaceX aiming to do with Starship's 12th test flight?
Well, so okay, I'd say let me challenge you on that, Brendan. Like, getting it off in two is impressive if you're held to sort of the standards of you have astronauts aboard or a paying customer. SpaceX has neither of those things on Starship, and so
fair
really,
point. I will give you that.
As long as the weather's okay, it's like
they're gonna go. Yeah,
they're gonna go, and more. As you know, failing is very much part of their culture and ethos, and part of how they build. And so this test flight was pretty bog standard by now, as the British would say, and I'm a little bit British myself, so I say it too. But basically, this is the same test flight we've seen many times before, which is they launch it into a suborbital trajectory, they fly it out over Africa, and then it re-enters and lands in the southern Indian Ocean. And the booster is supposed to come back. Sometimes it lands at the tower, sometimes it lands in the ocean. This time it was going to land in the Gulf. So interestingly enough, there were a few new things. They had some satellite launching they did, but really this looked very much like probably the last half dozen Starship flights, if not more. So that was interesting in and of itself to me, because there is progress, and yet there kind of isn't progress, and we could talk about that too if you want.
There are two different kind of people watching these Starship flights, right? The private industry, which we'll talk about a little bit later, but also NASA, right? Starship is one of the contractors that is, or one of the vehicles that is contracted to bring astronauts to the surface of the moon. And as you mentioned, it doesn't seem like there is a lot of development when it comes to this. Where is Starship on track to meet the obligations that NASA has for it?
Oh, come on, Brendan. You know this. You don't need to ask me this. What do you think? Are they on track?
It doesn't look like it. It doesn't look like it. You're right.
It doesn't look like it. I will say version 3 did have one thing, which is they had these refueling drogues on the side of the rocket where theoretically this Starship could eventually refuel on orbit with another Starship. Those seem to me kind of aspirational, right? Like, I remember years ago, North Korea paraded a missile, a big ICBM type missile, and everyone looked at it real closely and they're like, that's not really a missile. That's just a bunch of, like, it's designed to look like a missile. But what it was doing was showing, we're going to make this missile someday. And I felt that way about these refueling ports on the side of Starship. I don't think they are hooked up to anything. Like, I don't think they did anything, but they were there to kind of show that this was the direction. Anyway, yeah, Starship is way behind. I think you know that. It's so far behind. It sort of boggles the mind what would need to happen, because, okay, now we're going to get into your area of expertise. When are they supposed to land? Artemis 4 now, right?
2028. 2028 is the goal.
2028. Mm-hmm. Okay. I mean, the Elon stands will say he can do it.
Mm-hmm.
They got a long way to go. They
Mm-hmm.
got a long way to go before they can.
You're listening to Are We There Yet? The radio show exploring space exploration from Central Florida Public Media. I'm Brendan Byrne. We're speaking with Geoff Brumfiel, a senior editor and correspondent at NPR, about SpaceX's Starship. So we've been talking about kind of the challenges that Starship is facing, Geoff, but there were some successes on this flight. Tell us a bit about what actually happened on this flight.
There were some successes and some failures. And again, I would say this feels very familiar to anyone who's been watching Starship. So the liftoff was probably, in my opinion, the most impressive part because, as I said, they had these new Raptor 3 engines, much more powerful. And when those hold down clamps lifted, the engines were at full power already. And unlike other Starships, which have lifted off very, very slowly, this thing shot up like a rocket. So that was really impressive to watch. And like, as someone who's watched, I think all the Starship launches, most of the Starship launches, that was a really noticeable change, was how fast it moved off the pad. Now, also notable, given these Raptor 3s have never been to space before, the fact that they had one failure, I think, on the Super Heavy booster, so 32 of 33 worked, great, really impressive. The problems began when the booster separated from Starship itself. And so in very quick succession, you had the booster fail to relight, so that it started tumbling back to Earth, but it wasn't flying back in an intentional way, the way it was supposed to. And then Starship lost one of its vacuum engines, vacuum Raptor engines. So one of the big ones. Now, Starship was able to continue on its flight, but I think losing that engine forced them to scrap the engine relight in orbit. And then the booster tumbled back to Earth and was lost. It exploded somewhere on the way down, or when it might have slammed into the water. It's a little unclear when the telemetry went out. There were other things that went right. The reentry looked pretty smooth. The deployment of these dummy satellites looked pretty smooth, but it had hiccups, and that's very consistent with what we've seen recently from Starship. We have not had a clean flight yet, and that's a problem, right? Because why is the engine relight so important? So to actually put Starship into orbit, they have to prove they can reignite the engines while in orbit to deorbit the spacecraft safely. And so if they can't do an engine relight on these suborbital trips, they cannot go to orbit. So we're going to get another suborbital flight. We're going to get another Starship test that looks very much like the last one we just had. And that just slows the program down more. So, mixed bag, I'd say.
Finally, Geoff, you've been following the business of SpaceX for a very long time as correspondent with NPR, and this going public, this filing by SpaceX gave you a lot of insight into actually how SpaceX works. What was the most surprising thing out of these documents?
Oh, I think the main thing is that SpaceX is losing. Hold on, let me look it up. Stand by. Here it is. So it is SpaceX is losing close to $5 billion a year. So that was very surprising to me, because this company is so hyped that it could be losing that much money was pretty interesting in my mind. And it all comes down to AI. The AI side of the business, XAI, which merged with SpaceX in February, is a flaming black hole into which money is being thrown at an unimaginable amount. The Starlink business is making money. The rocket launch business is losing money because of Starship, the aforementioned, much discussed in this episode, Starship. But if they scaled back development or did something differently, they could probably stabilize that. But the AI side of the business is just hemorrhaging money. And so it's going to be very interesting to see how they can balance all these needs to develop this very expensive rocket, to do all the things they claim they want to do, while losing money. Oh, and they're $30 billion in debt. But who isn't these days?
Well, I'm sure you will be following that throughout the summer, and as SpaceX continues to throw money at artificial intelligence. Geoff Brumfiel is a senior editor and science correspondent at NPR. Geoff, thanks so much for joining us.
Thank you, Brendan.
Still to come, what holds our galaxy together? A new telescope launching later this year wants to find out how the Roman Space Telescope will search for galactic glue. That's ahead on Are We There Yet? You're listening to Are We There Yet? From Central Florida Public Media. I'm Brendan Byrne. We're going to talk about a new telescope that's set to launch to space soon that could help us uncover one of the most elusive mysteries of the cosmos. But before we do that, I'm asking you for some help for a future show. Do you have a curious kid who has a question about human spaceflight? Curious Space is an occasional segment here on Are We There Yet? Where we take questions about living and working in space from our youngest listeners and have an actual astronaut answer them. It can be about anything, from what it's like to eat space food to how to use the space toilet. We want to hear them all. If your young space enthusiast would like to submit a question, here's how you do it. Record a voice memo on your phone with them asking the question. Be sure to include the kiddo's first name and age. Then send that voice memo to us. Our email is arewethereyet@cfpublic.org. We may use that question for a future episode of Curious Space. Thanks for your help. And now it's time to talk galactic glue, or rather the telescope that might help find it. The development of the Nancy Grace Roman Space Telescope, or Roman for short, is complete. The spacecraft will launch to space sometime this year, and the project is under budget and ahead of schedule. It will search for two mysterious things in the universe. It will help find exoplanets, or planets outside our solar system, and it will help detect dark matter, the key to understanding how things in the cosmos stick together like our galaxy. Mark Melton is NASA's Roman Mission Systems Engineer. Mark joins us from inside the clean room at NASA's Goddard Space Flight Center, along with the telescope, so you might hear some noise from his colleagues that are making final preparations on Roman. Mark, welcome to Are We There Yet?
Thank you. So excited to be here.
Yes, and it looks like you are in a very exciting location. For those listening to this on the podcast, tell me what is behind you. You are in a full bunny suit here, full protection, because there's some very important cargo just above your shoulder there, isn't there?
Exactly. So the Nancy Grace Roman Space Telescope is behind me. We have our aperture cover open right now, so we're doing some final cleaning of that, and we just did some optical checks. So we want to protect the mirror from any contaminants. As, we humans are the dirtiest things that we allow in this clean room.
Sounds good. So it looks like you're making final preparations for launch, which I know is coming later this year. Can you tell us what is the goal of the Roman Space Telescope?
So we are launching to help answer some of astronomers and astrophysics big science questions. Uh, Primary one is how has dark energy and dark matter influenced the expansion history of the universe? And also, we're looking to understand how planetary systems outside of our solar system, inside of our galaxy, evolve and what they look like.
hmm Mark, how is this telescope going to do that? Let's start with dark matter. How is it going to find that? Because that's quite elusive, isn't it?
Yeah, so dark matter, we can see its influence when we look at the other galaxies. We can tell by the way they move that there's mass that we can't see. And so our surveys are designed, huge surveys, to map about 10% of the sky to help us gather data to understand what that dark matter is and how it's shaping galaxies.
hmm How is that going to help us understand our universe by understanding dark matter and finding it?
So, both dark matter and dark energy have really shaped how the universe has formed. For years, we assumed that after the Big Bang, the universe started expanding, and we assumed that it would eventually start to slow down because the gravitational pull of all the galaxies in this system would start pulling it back together. But instead, some force, and we don't know what that is, called dark energy, actually started pushing them away faster. So if you think about throwing a ball up in the air, instead of slowing down and coming back to you, it actually shot off into the sky. So that force, we don't know what it is called dark energy. So trying to look essentially back in time as we look back billions and billions of years at how the galaxies separated, to try to understand what that phenomena is.
Hmm. That's the coolest thing about astronomy is that you are looking into the past. You're collecting all of this light that's been out there for billions and billions of years. Tell us a bit about
Exactly.
the tell us yeah, it's cool. Tell us a bit about the hardware on the Roman telescope that is able to do that. How is it able to look back in time that far and see this?
So we're observing an infrared light. And if you're familiar with the Doppler effect, where the frequency of sound changes, if you hear a siren, it sounds different as it's coming towards you and moving away from you. Light will change its frequency or color as it moves. So we're looking in the infrared light so that we see it now from what it looked like back billions of years ago. We have
Hmm.
these little detectors. They're 4,000 by 4,000 pixels. We have 18 of them. Think of an H or a 4K TV is about 4,000 by 2,000 pixels. We're cramming 4,000 by 4,000 pixels in about a couple square inch detector. Each of those pixels is only about 10 microns, which is about 5 to 10 times smaller than the diameter of a human hair. So that technology is what enables us to look back and get this really large field of view that we have, 1 to 200 times that of Hubble, to collect all that data that we need to help answer those big questions.
Hmm. How is that data going to get sent back to us? I would imagine with all of those pixels, you are creating these massive image files, for lack of a better word, that you have to beam back to Earth. How is that going to happen?
Exactly. So we have a big antenna. It's about 5 feet 7 inches in diameter that we're sending the data down to the Earth. It's about 11 terabits per data a day, or about 1.4 terabytes a day that we send down. The ground system
Wow.
processes that super fast, and it's available publicly out in the cloud within just a couple of days for any scientist in the world to look at that data and try to, you know, find their own, their own science cases that they're building with this data.
Hmm. Terabytes of data. That has got to have astronomers down here on Earth so excited to get their hands on that.
Exactly. It's
Yeah.
something like, I think in our first year, we'll have sent down more data than Hubble has in its entire lifetime. It's amazing amount of data.
That is incredible. That is incredible. Um, I also want to talk about something that excites me and something we talk about a lot on this show, and that's the search for exoplanets, because Roman is going to help with that as well. How will this
Exactly.
telescope help us find planets that exist outside of our solar system?
So we have two ways of doing it. Our wide field instrument, which is doing those large surveys for dark energy and dark matter, will also be pointing that instrument at the center of our galaxy, and we'll be using a technique called gravitational lensing to complete a census of planets that Kepler started to help us understand where planets are in their solar system and how big they are. We for years thought that planetary systems must look like ours, but small rocky planets, and you're their star, and then big gas giants. And Kepler has found that that's just not necessarily the most common thing. And so we're helping to understand that with the survey. We also have an exoplanet chronograph, which will allow us to directly image planets around nearby stars. That will have about 100 to 1,000 times better capability than anything that we've flown to date, and it's really leading the technology development there for a future instrument that could directly image an Earth-sized planet in an Earth-sized orbit to help us start answering questions of maybe are we alone?
Hmm. I don't think you hit on how important that is. I mean, we're going to be able to image a planet that exists outside of our solar system thanks to technology that is on the Roman Space Telescope. That's right.
Yes, exactly.
Wow, very, very cool. You're listening to Are We There Yet from Central Florida Public Media. I'm Brendan Byrne. We are speaking with Mark Melton, the Roman Mission Systems engineer. Mark, I want to talk about the systems of the Roman telescope, but more importantly, how it's going to get where it needs to go. It's set to launch later this year. Walk me through launch day and those first few moments that Roman is in the sky.
Sure. Well, after we launch, we go into a very brief parking orbit until the rocket can put us onto a trajectory toward our final orbit, which is at the Sun Earth L2 point, is what we call it. It's about 1 million miles behind the Earth, in line with the Sun and the Earth. Within about 20 minutes of separating from the launch vehicle, we will have reoriented ourselves to make sure that we're on the sun. and we start to deploy our solar arrays so we can maximize our power on orbit. About a day or so after that, if necessary, we have thrusters on board to do any slight corrections if there were a little bit of uncertainty in where the launch vehicle put us, so we can get exactly where we're going. And then we'll start deploying our cover and our antenna and start commissioning tests of the observatory to check it out on orbit before we start the full science mission.
Hmm. Mark, I'm able to see this telescope for our fans that are listening to us on social media. Will see this as well, but give me a sense of scale. I see one of your colleagues walking below it right there, and they are very small in comparison to this telescope. It's huge.
Yes. So the mirror itself is the same size as Hubble's. It's 2.4 meters, or about 8 feet in diameter. The full observatory, when the cover is open as it is now, and our antenna at the bottom is deployed, is about 42 feet tall. So it's
Wow.
massive. When the solar arrays are fully wide open, it's about 20 feet wide. So it's massive.
Hmm. A lot has to go right to get it into where it needs to be at that L2 point mark. What is the moment of this mission that's still keeping you up at night? What is the most critical part of this mission for you?
I think just making sure that all of our we have a few deployables that we have to get working. We have to get the cover open, as you see right now, get the solar arrays out. Of course, we've practiced that many times. We've subjected them to tests where we vibrate the entire observatory and then confirm they open. So while there's always risk in missions, we've really done all the testing to be confident that this mission's going to work and achieve all of its science goals.
Finally, Mark, I want to ask you, the goals of this mission are quite ambitious, but will change the understanding of how our universe formed, and also that direct imaging of a planet outside of our solar system that will help us find worlds that could be like ours outside of our own solar system is incredible. Can you just put into words just how exciting it is to work on a mission like this that has the potential to be so groundbreaking to our understanding of who we are and where we are.
Yeah, I mean, this has practically been my life's work. I started in this project in 2008, so I'm just thrilled to help in a small way to help, broaden the knowledge of the science community with this amazing observatory.
That was Mark Melton, NASA's Roman Mission Systems Engineer. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on Apple Podcasts, Spotify, or wherever you get your podcasts. Stay connected with this show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTY Space. And if you got an idea for a future episode of this show, or you'd like to join us as a guest, well, reach out. Our email is arewethereyet@cfpublic.org. Are We There Yet is a production of Central Florida Public Media. Our producer is Marion Summerall. Editorial guidance comes from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.